All right, we're almost done. Page 4 of the notes for section 10.5 coming right up. I think these ones are interesting. I like these ones, so I'm really looking forward to it. I even took my hat off. This is how I'm looking these days. Great Clips is shut down, so I got to deal with it. Okay, example 7. Simplify the expressions. We've got the third root of 5 times the fourth root of 5. Okay, cool. So these are not like radicals, but we're not being asked to add or subtract, we're being asked to multiply. You do not need like radicals when you're multiplying, okay? So what can I do here? Well, I think what's helpful is to know how to convert these from their radical form into their exponential form. The third root of 5 is also known as 5 to the 1/3 power times the fourth root of 5 is also known as 5 to the 1/4. I almost messed up there, but no. Okay. Now look, you got similar bases, the same bases, different exponents. The rule is you do what to the exponents? You add them. So I need to do 1/3 plus 1/4. That's common denominator of 12. So that's going to be 4/12 plus 3/12 equals 7/12. Okay, so this becomes 5 to the 7/12. Now look, that's a legit answer. I would accept that. I would give you full credit. But why not convert it to the radical form? Okay, can you do that? Yeah, so the radicand is 5, the exponent is 7, and the index is 12. So this is the 12th root of 5 to the 7th power. Yeah, circle it. It's done. Okay. The next one. Now this is the one that I thought was interesting, because you've got 3, or it's the third root of 7 times the square root of 2. Okay, so now not only are the indices, the indexes, different, but the radicands are different too. So, like, what do, right? WTF, what the fraction? So, well, let's just try to do the thing we did before, convert it to the exponential form. This is 7 to the 1/3 power, and this is 2 to the 1/2 power. Right? It's not super helpful. Okay, here's what I'm going to do. I'm going to convert these into fractions that have the same denominator. So check this out. I'm going to get 7 to the 2/6 times 2 to the 3/6. Take a second, convince yourself that what I did is legit. It is, okay? Then what I'm going to do, and this is the tricky move, I'm going to take a 1/6 out. I'm going to factor out a 1/6 from each of these. So if I factor out a 1/6 from this, that leaves me with, what does that leave me with? Oh, it leaves me with just 2. Yes. If I factor out a 1/6 from this, that leaves me with 3. Okay? And I factored it out. Where does it go? Well, I factor it out and I pull it outside of these parentheses. Okay, now again, look at this to make sure it makes sense. If I multiplied this back out, if I applied the exponent rule, I multiply this times this. If I do 1/6 times 2, guess what you get? You get 2/6. If I do 1/6 times 3, guess what you get? You get 3/6. So this is legit. And it's cool now because now I just have some regular numbers. I can do 7 to the 2nd power. That's 49. 49. 2 to the 3rd power is 8. And it's still all to the 1/6 power. Yeah, and then I guess the only other thing I can do is I can just take 49 times 8, which according to my calculations is 392. So this is the sixth root of 392, because 1 over 6 is the sixth root. Whew, yeah, that's a tricky one, okay? We should probably do another one, okay? Let's do the last one. Looking forward to the weekend. Can play some pool out in my garage in a little bit. It's going to be awesome. Okay, what do we have? We have the fourth root of a to the third times the third root of b to the first. Okay. All right. You look at something like this, you're taking a test, you're taking a quiz, you're doing your homework, whatever. You freak out because it looks complicated. If all else fails, put it into exponential form. The fourth root of a to the third is also known as a to the 3/4, okay, times. The third root of b is just b to the 1/3, okay? And then you continue to freak out because I'm like, this doesn't help, I don't know what I'm supposed to do from here. Well, if all else fails, let's get these fractions to have the same denominator. So that would be a to the 9/12 times b to the 4/12. Yep, that works. All right, well, why did I do that? I did that so that I can now factor out that common denominator. I'm going to get a to the 9th times b to the 4th, and what did I factor out? I factored out 1/12. Great. Oh, now I'm pretty much done. Like, I just need to put this in radical form and I'm good to go. This is a 12th root, and then underneath the radical is all of this. Have a great weekend.